Listen closely. You're about to hear an auditory mystery that has baffled tons of people. Ready?
Yelly. Yelly. Yelly.
Okay, now listen again. If you haven't heard it before, get ready to join a very heated debate.
Yelly. Yelly. Yelly.
What did you hear? Yanny or Laurel? If you're listening with a friend, you may have to argue it out because different people hear different things. The real answer is hiding deep within our minds. From GBH in Boston, this is Nova Remix. I'm Caitlin Sachs. The human mind is incredibly complex, and its depths elude scientists even today. There are aspects of it that perceive, remember, and make decisions even when we aren't aware of it. That begs the question, are we even in control of our own minds? But before we get too deep, let's settle the debate. Whatever you think you heard, there are plenty of people who disagree.
Once and for all, is it Yanny? Is it Laurel?
It's not Yanny, it's Laurel. It's Yanny.
It is Laurel and not Yanny.
About half of us hear Yanny and the other half Laurel. How can that be? Who's right? It turns out the audio signal is made up of both high and low frequencies, which makes it especially deceptive. As listeners, some of us gravitate towards the high frequencies and others toward the low frequencies. To prove it, we can manipulate the frequencies and change what you hear. If we turn up the frequency,
Yelly. Yelly. Yelly.
and then turn down the frequency,
Yelly. Yelly.
Yelly. Yelly.
Laurel. Laurel. Laurel.
so everyone was right. And all of this goes to show that we don't fully control how our minds work. You didn't knowingly preference one frequency over the other, did you? People were certain they heard Yanny or Laurel, but buried in their minds was a slight preference for a high or low frequency sound. Like it or not, our perception of the external world is not completely reliable, and our minds are often made up before we even make a decision. Neuroscientist Dr. Stephen Macknick explains.
Most of the world around us is very real, but you just never lived there, okay? You lived in your mind, which is a perception of that world that's being filtered through a bunch of saltwater sacs of proteins and electrochemical signals, which can't possibly be making completely accurate determinations of what's actually in the outside world.
But if our minds are so sophisticated, why would they be so imprecise? What good does that do? Think of it another way. It's like the brain is not a perceiving machine, but a predicting machine.
The brain is using sensory information to calibrate, update, to fine-tune these predictions so they remain tied to reality in ways that are not constrained by accuracy, but that are constrained by how useful the brain's perceptual predictions are in the business of staying alive.
Neuroscientist Dr. Anil Seth is saying that our amazing minds have evolved to complete incomplete pictures. Basically, to predict the future. This is why we flinch before we get hit, or how we can catch a ball without using calculus to figure out its trajectory. It allows for a split-second understanding of our surroundings, and from there, our minds complete the picture. Your brain serves you well and does this all day long. But sometimes a hiccup occurs unconsciously, skewing your perception. Yanny and Laurel is just an example of how the brain samples data from the world, in this case sound, to jump to quick conclusions about reality. But the brain does so much more than that. It stores memories, controls our bodies, and even shapes our personalities. With each of those functions, there are other hidden tricks that the brain uses to be more efficient, and sometimes create some strangeness in our daily lives. For instance, sleepwalking.
Well, I've been doing some weird things. I painted a wall in my living room and one in my kitchen. I made a triangle, a perfect triangle. I laugh because I go, what the heck, I did this.
That was an individual who suffers from sleepwalking. To respect their privacy, we won't be sharing their name. But some nights, they perform complex tasks all while they sleep. Neurologist Dr. Emmanuel During explains.
Sleepwalking is a glitch in the system because our identity is not in control. You sleep, but during your sleep, you will walk. We take it for granted, right? But the walking is extremely complex. Just teaching a robot all the inputs and outputs for a body to move forward on two legs without falling. All of this, you don't even think about it. It works independently.
How is it possible to perform complex behaviors like walking, eating, and sometimes even driving while sleeping? And more importantly, are we in control or is something else at work? During uses EEG to track his patients' neural activity as they sleep. Normally, sleeping patients go through cycles of high and low neural activity. When the brainwaves slow down, scientists call this deep sleep. But when someone sleepwalks,
there's part of the brain stays in slow wave sleep. It's such a deep stage of sleep. It's hard to wake up, and the other part of the brain is already awake.
During points out that parts of the brain are still asleep while others wake up. One part of the brain that doesn't wake up during sleepwalking is called the prefrontal cortex. It's the region of the brain responsible for deliberate choices and self-awareness.
This prefrontal cortex is the decision maker. The other areas of the brain can mostly work independently of that. Essentially, so many parts of the brain can be engaged without conscious awareness of it.
While sleepwalking, the motor cortex, the visual cortex, and the parts of the brain that coordinate behaviors like balance and speech can all become active without engaging the prefrontal cortex. That's the decision maker. That's probably why these patients wouldn't say they're in control in those moments. But then again, parts of their own brains are fully awake. So who is deciding to sleepwalk? Come to think of it, our bodies take on a mind of their own all the time. Neuroscientists Dr. Nancy Kanwisher and Dr. Daniela Schiller break it down.
For starters, boring stuff like regulating your heart rate and your temperature, deciding when to take the food in your stomach and move it down into your gut. Like, thank God we don't have to be aware of all that stuff. Motor function, sensory function, motor sensory integration, memory representation, all of this is happening below the surface, like the inside of clockwork.
This means different parts of our brain control different functions, and those separate parts can be deactivated while others continue to do their job. So, in a way, part of you is in control in that moment. You just aren't actively conscious of it. But does that really feel like control?
I think most human beings like to believe that their mind is under their own control. If I want to, I can stand up right now. I can do that. And that gives me, I think, the false belief that everything I do has been chosen by me. And if there is a story from the brain to tell, it is that we are quite wrong.
Psychologist Dr. Mahzarin Banaji is saying we've fooled ourselves into believing we have full control. And that's because the idea of you is actually shared between almost 90 billion neurons that make up over 100 distinct regions of your brain.
Each of us has a sense that we're a unitary being, but actually that belies the fact that each of us, each of our minds, is actually composed of lots of different pieces that are doing different things. And different information can be represented in different parts of that machinery. And so a search for where am I in all of this is a little bit misguided because the I is not such a unitary thing in the first place.
Nova and Nova Remix are supported by Carlisle Companies, a manufacturer of innovative building envelope systems. With buildings responsible for over a third of total energy use and energy demand on the rise, Carlisle's mission is to meet the challenge head-on. Carlisle's advanced, energy-efficient, and labor-saving solutions can help reduce strain on the grid. Operating nearly 100 manufacturing facilities across North America, Carlisle is dedicated to helping the transition to a smarter, more sustainable future. Learn more at carlisle.com. Nova and Nova Remix are sponsored by Viking Cruises. Ocean voyages, expeditions, river journeys, Viking is dedicated to bringing travelers closer to the destination, offering a small ship experience and a shore excursion in every port. Learn more at Viking.com. So, our brains are actually composed of different pieces that are doing different things, sometimes completely independently of one another. That might be a lot to take in, but neuroscientist Dr. Talia Wheatley has a story that will help demonstrate this idea.
Phineas Gage was a railroad foreman who was working in Vermont, and he was tamping down a hole that had gunpowder in it, and the gunpowder ignited, sending the rod through his eye, up through his brain, taking out a big patch of his brain in the process. At first, people thought, well, this is a miracle. This man has been unscathed from this accident. He had memory, he had language, he had motor control. But of course, his friends noticed a difference. His personality made him more fitful, irreverent, more profane. He was cursing a lot, lewd behavior, so he had sort of no filter. We now know that the parts of the brain that he sort of surgically excised were involved in emotion and control. And that was the key moment, I think, in neuroscience history when people realized, oh, it's not just that motor, memory, language is in the brain. Your personality is up there. Your morality is up there. The things that make you, you are there.
So Gage continued life after his accident. For all intents and purposes, he was functioning, just with a new attitude. Most of Gage's brain was still intact after the accident, but without the portion he lost, he seemed like a different person. This further supports that we are spread across multiple portions of our brains. So that should mean that if our brains are fully intact and we are fully conscious, then we are in control of our decisions, right? Even if there are unconscious accidents now and again, together it all adds up to who we are, and we can finally be certain of our own agency. Not so fast. It turns out that external forces outside our minds also play a role. Postdoctoral researcher Dr. Alice Wong designed a trial that tested just that. In the trial, a volunteer is fitted with a transcranial magnetic stimulation device. It's basically a cap that generates a magnetic field and sends signals to your brain. Signals that can make you move.
The idea is that you stimulate the brain using a focused magnetic field, and if you stimulate that in the right part of the motor cortex, it's a part of the brain that actually controls your fingers. It's like you're pulling on a string here. Every time you pull it, the finger goes.
That was Dr. Ori Maus, a neuroscientist working with Wong. By making the finger move, they can then ask the participant to replicate the action themselves, and then record the signals that travel from the participant's brain to their finger. With this information, Wong and Maus can pinpoint the exact moment that the participant's brain had initiated a movement, almost 50 milliseconds before they actually move. It's as though they can predict the movement slightly before it actually happens.
We're going to be locating the spot of your motor cortex that moves one of your fingers. How about that?
That works. That was a pinky movement up.
Okay. Could you replicate the movement?
And if they can predict it, they can preempt it. In some instances, just as the participant decides to move their finger, the researcher's computer uses the magnetic field to make the finger move itself. Wong demonstrates with fellow postdoc Dr. Tomasz Dominik.
Who initiated the movement?
I really don't know.
Okay. How much agency did you feel over the movement?
A little bit.
So even when the participant really did decide to move their finger, they didn't always feel like they were in control.
When Tomasz initiated the movement himself, yet we intervened with the TMS, Tomasz said, that wasn't me. I didn't initiate the movement. It was the computer. He thought that the computer initiated the movement, or it was both of them, or he wasn't sure, but he almost never said that it was him.
But surely he knew if he moved his own finger, right?
You know, we walk around and we feel like, you know, we are the authors of our actions and so on. And you can see with just a little bit of messing around, it tends to fall apart. Everything has to align for you to feel this sense of agency. When the finger moves, we get this feedback back to the brain, and it's incorporated with whatever is happening in the brain to create the movement. And together, you get this sense of agency over the movement.
We think A happened and then B happened, that's the end of the story. But of course, most of our brain activity is unconscious.
So we sometimes misinterpret. Our experience of voluntary action is a little bit retrospective in this sense. The brain looks at what the body did and figures out if that makes sense as an act of its own free will.
That was Dr. Anil Seth again. And just like in Wong's trial, he's saying that our sense of agency not only depends on how the brain functions, but it also relies on how we perceive and remember the action. Remember Yanni and Laurel? Just like our perception of sound can be changed, our perception of our own agency can be influenced.
I think of agency as a sense. So there is a sense of agency that sometimes can get disrupted, perhaps, just like you have a sense of sight or smell and so on. Sometimes you have visual illusions. It's similar with a sense of agency. I can manipulate your sense of agency, but that doesn't mean that we never have a sense of agency.
If agency is just another thing we perceive, is there any way to figure out if we're really in control of our brains? Then again, why do we so badly need that validation? After all, there are some people that don't always need control. They just go with the flow. And letting go of conscious control can have some amazing results.
When you're playing the blues, you have this kind of well-known musical structure, this template, and then you use that as a launch pad for improvisation, for innovation, and for new ideas.
Dr. Charles Lim is a neuroscientist trying to understand how our brain operates when we are being truly creative. Nova tagged along as Lim used a scanner to peer into the brain of educator and freestyle rapper Dr. Chris Emdin.
It's gonna be ill in the MRI. It's Dr. E freestyling, somewhat on a limb. About to hanging out with Professor Charles Lim to find out what's going on in my brain.
Okay, remember, keep your head still during the entire thing and try not to move your feet or your hands at all during the rapping.
All right, do the best I can.
Yeah, awesome, thank you.
First, Lim asked Emdin to perform a memorized piece.
Now that memory means you're gonna do the memorized lyrics the way you originally wrote them, okay?
Okay.
Memory.
I'm a physicist, lyricist, spitting this ridiculousness, so witness the ignorance I dismiss. Knows those emotion is a topic of
Next, Lim gave Emdin a prompt and asked him to improvise, to create a new, totally original piece on the spot.
Freestyle, physicist, lyricists, MCs like this will always be kicking this. After all the matter, it'll all be over. Lucky like I picked up all the clover. Can't move my shoulders because the MRI machine won't let me do it. But you want to know what it is that it's like.
So, what does improvisation, or spontaneous creativity, look like in the brain? Lim's study gave insight on which regions of the brain are activated when a musician performs a memorized piece versus an improvised piece.
What we found was that the prefrontal cortex that appears to be linked to effortful self-monitoring seemed to be turning off, deactivating, in a pretty intense way in these highly trained professional musicians when they start improvising. In fact, if you're too self-conscious and you're unable to relax and let go, you can't do something like this. When you start trying to put conscious control mechanism, your performance goes down. Free throw shooters that are able to shoot 99% free throws, all of a sudden, when you tell them you're gonna get $1 million if you make the next one, then all of a sudden you inject conscious control over something that's much better just left to its own subconsciousness, and then your performance gets worse and you're more likely to choke.
Surprisingly, the parts of your brain that are usually in control can get in your way. Your prefrontal cortex, the decision maker, can make you overthink something you've done 1,000 times.
Every human being is creative. Whether they're creative artistically or not is another question, but we're all creative. We have to be, because all day long we're doing unscripted things that we didn't know we would be doing. Life is not scripted. You have to let go of conscious self-monitoring to just kind of like go with the flow.
Just go with the flow. It can be scary to hear, but if you think about it, subconscious forces already exert a lot of influence over us. That's their job, to think for us while our conscious mind is busy elsewhere. It can create some occasional strangeness in our lives, but then again, exerting too much conscious control can make a mess too. Maybe it's okay that your brain has a mind of its own. In the end, it's still yours. This has been an episode of Nova Remix. Subscribe for more episodes and drop us a comment with your thoughts or questions wherever you get your podcasts. And if you want to learn more about our amazing minds, check out our 2 documentaries, Your Brain, Perception Deception, and Your Brain, Who's in Control, on Nova's website, YouTube channel, and the PBS app. Nova Remix is a series from GBH and Nova, and it's distributed by PRX. Executive producers are Julia Court and Chris Schmidt, and Senior Director of Digital Media is Nadia Petchek-Rawls. Devin Maverick Robbins is Managing Producer of Podcasts for GBH. This episode was produced by Chris Neighbors with sound design by David Porter. I'm Caitlin Sachs.